Everyone, welcome. Today we're diving into a math adventure, solving equations and inequalities. Whether it's about saving money, getting candy, or understanding grades, these math skills can help you in real life. Let's jump in. Let's say you're saving up for your favorite video game. You already have some amount of money, and your parents agree to give you a little more each week. The question is, how many weeks until you can buy the game? This is not just a money problem, it's an equation. Let's dive in. Solving one-step equations. One-step equations usually include a variable, like x, which is the unknown that we're trying to find. These are equations that you can solve with one step by either adding, subtracting, multiplying, or dividing. Let's take this example here. X plus 7 equal to 10. We subtract 7 from both sides and we get x equal to 3. What about this one? Z times phi equals 25. We divide both sides by phi, which gives us the result z equal to phi. Now what about multi-step equations? Multi-step equations require more than one step to solve. You might need to distribute, combine like terms, and use inverse operations like adding, subtracting, multiplying, and dividing. Let's take this example here. 3x plus 4 equal to 16. Step number 1, subtract by 4, and this gives us 3x equal to 12. The next step would be dividing by 3, which gives us the value x equal to 4. So the solution is x equal to 4. What about this one right here? 2 times z minus 3 in parentheses is equal to 10. First step is to get rid of the 2, or distribute the 2. So it would be 2z minus 6 equal to 10. Then we add 6 to both sides, and that would be 2z equal to 16. Then we divide by 2, which gives us z equal to 8. Another way to do this was to divide by 2 first, which would give us z minus 3 equal to 5, and then just add 3, which would give us the same value, end result z equal to 8. Now, solving equations with variables on both sides. An equation with variables on both sides means both sides have an unknown, like x. To solve, get all the x's on one side, the unknowns, and the numbers on the others. Let's take this real-world problem. You and your friend are both collecting candies. You have 5 candies to start off with, and you gain 2 each day. Your friend has 1 candy to start off with and gains 4 each day. We know for sure that one day we'll both have the same amount, but we need to find what day that is. An equation with variables on both sides help us figure out when that happens. Let's say z is the number of days the candies are being collected. You get 5 candies, the starting point, plus 2 times z, and your friend collects 1 candy, plus 4 times z, 4 per day. We both have the same number of candies at the end, so we can set 5 plus 2 times z and 1 plus 4 times z equal to each other. And we see that right here. The first step is to subtract 1 from both sides, which gives us 4 plus 2z equal to 4z. Then we take 2z away from each side to get the z's on one side and the numbers on the other side, and that gives us 4 equal to 2z, and then finally we divide by 2, which gives us a value z equal to 2. After 2 days, you and your friends will have the same number of candy. What about this example? 3x plus 6 equal to 2x plus 10. Subtract 2x from both sides, that gives us x plus 6 equal to 10. But don't forget, we need to group the numbers together on the other side. So now we subtract 6 from both sides, and this gives us a value x equal to 4. So both sides are equal when x equal to 4. Solving and graphing inequalities. Inequalities are like equations, but instead of saying two things are exactly equal, we're saying one is greater less than, or not equal. I need at least $10 to buy lunch, let's say. And that means it's any number greater than or equal to 10, because I need 10 as a minimum, or I can also have more. These kinds of inequalities help us describe a range of possible answers, not just one answer. This means less than. Well, this symbol here means greater than. And this means less than or equal to. And that means greater than or equal to. We use these symbols to write out inequalities. And solving inequalities works just like equations. We can use inverse operations to isolate x. One special rule: if you multiply or divide by a negative, you must flip the sign. Let's see this. Y plus 3 is less than 10. Subtract 3, we get y less than 7, which is the solution. Here, negative 2x is greater than 6. Here, we know we have to divide by a negative, so we must flip the sign. So, dividing by negative 2 on both sides gives us the value x is less than negative 3 as a solution. Compound inequalities. Here's a real-world example. You're allowed to be in a school cafeteria only if it's after 11:30 a.m. but before 1 p.m. It's a time range, and that's what compound inequalities do. They show when something is between two values or outside a certain range. Here are some inequalities graphed on a number line, but let's look at solving and/intersection compound inequalities, where they have to be between a certain range. So 3x plus 1 has to be less than 4, and negative 2x plus 2 has to be less than or equal to 8. We solve each of these by itself, but at the end we group them. So 3x plus 1 less than 4, that means subtracting 1 from each side, we get 3x less than 3, and then x would be less than 1. But we also need to consider this side. Negative 2x plus 2 is less than or equal to 8, negative 2x less than or equal to 6, and then x greater than or equal to negative 3, because we have to flip the sign as we're dividing by a negative. And then, since it's an and, that means we need to combine these. So negative 3 has to be bounded, and 1 also has to be bounded. So it's negative 3 less than or equal to x less than 1. Absolute value equations and inequalities. The absolute value of a number means how far it is from 0 on the number line, no matter the direction. It is always positive or 0. Here's some examples. Absolute value of phi is just phi, and 5 is 5 units from 0. Absolute value of negative phi would be 5, so negative 5 is also 5 units from 0. And 0, the absolute value of 0 is equal to 0. So that means 0 is also 0 units from 0. Absolute value remove the negative sign, because it's only about distance and not the direction. Let's talk about the distance between locations. You live at house number 12 in some housing complex, and your friend lives at certain house number X. We want to know how far apart we live. Let's say the distance between your houses is going to be phi. Then the inequality setup would be the absolute value of x minus 12 is equal to 5, because we only know the distance, and 5 houses before or 5 houses after would still be the same distance if 12 was considered as the origin on the number line, if we were thinking about it like that. So case 1, after removing the absolute value, we can get x minus 12 equal to negative 5. And then we just add 12 to both sides, so x is 7. Or if we remove it, and then we can also say that it's still equal to phi, and then we would get x equal to 17. So your friend could be living at house number 17 or house number 7. Both are exactly 5 units away from house 12. Here's another example, grading curves. A teacher wants to give bonus points to anyone scoring within 5 points of 90. So that means, given a score x, if we subtract 90, it has to be, the absolute value has to be less than or equal to 5. This means that the distance from 90 must be 5 or less. So removing the absolute value, we write it as a compound inequality, and this would be -5 less than or equal to x minus 90 less than or equal to 5. And then to solve, we just add 90 to both sides. So 85 less than or equal to x less than or equal to 95. So students who score between 85 and 95, inclusive, will receive bonus points. Now you guys know how to do solving inequalities and as well as regular equations. Thanks for learning with us today. Keep practicing and you'll keep improving. See you next time.